Hey everyone, in this video we'll talk about the end behavior of polynomial functions. So let's say we have this polynomial function right here, f of x equals 6x to the fourth plus 3x cubed minus 2x squared plus 5x minus 7. So we have this very complex polynomial function. If we were to graph this by hand by putting inputs in x, it would take a very long time to graph it to determine the end behavior visually. So how do we determine the end behavior just by looking at the formula for this polynomial function? Well, what we're going to do with this polynomial function, and this works for any polynomial function, no matter how many terms there are, no matter what the degree is. This one has a degree of 4, and there are 1, 2, 3, 4. There are 5 terms with a degree of 4. It doesn't matter how many terms there are. It doesn't matter what the degree is. This works for any polynomial function. What you're going to do is you're going to take the leading term. So the leading term is the term with the highest exponent. This one has the highest exponent of 4. So the leading term is 6x to the fourth. So what you're going to do is take a look at this term, 6x to the fourth. This is the leading term. And you can determine the end behavior just by looking at the leading term as if it were a power function. So in the previous video, we learned how to determine the end behavior of power functions. And we did it by taking a look at a basic matrix. So if we just drew that matrix again, so k is positive or k is negative. Let's go ahead and draw this matrix again. And then whether it's even or odd. Because 6x to the fourth, if you were to look at this as if it were a power function, this is in the form k times x to the p. So is k greater than or less than 0? Well, our k in this case is 6, which is a positive number, so it's greater than 0. And is this an even or odd power function? So this is even because the exponent is 4, p is 4, which is an even number. So when we're done filling out this matrix, we're going to end up choosing the end behavior in this box right here. So let's just go ahead and just write down everything we know about this matrix. So if k is positive and the function is even, then as x approaches plus minus infinity, f of x approaches positive infinity. And over here, as x approaches plus minus infinity, f of x approaches negative infinity. And then for odd functions, we know that as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches negative infinity. And then if k is negative, then it's flipped. So that means as x approaches infinity, f of x approaches negative infinity, actually. And as x approaches negative infinity, f of x approaches positive infinity. So that's our matrix for determining the end behavior. And we are going to choose this end behavior right here because our k is positive, it's greater than 0. 6 is a positive number. And our function is even because the degree is 4. So this is the end behavior as x approaches plus or minus infinity, f of x approaches infinity. So that is the end behavior for this entire polynomial function. So all you have to do is take a look at the leading term of the polynomial function, and then you would determine the end behavior the same way you would for a power function. So I hope this video helps, and if you have any questions at all, please leave them down in the comments below, and thank you for watching.